Hello students! In this video lesson, we are going to talk about the nature of mathematical reasoning. Here are our learning objectives. At the end of this video lesson, you are expected to identify two types of reasoning, use inductive reasoning to make conjectures, find a counterexample to disprove a conjecture, explain the difference between inductive and deductive reasoning, and use deductive reasoning to prove a conjecture. Now, what is reasoning? Reasoning is a process of logical thinking, and there are actually two main types of reasoning. We have the inductive reasoning, also known as induction, and the deductive reasoning, also known as deduction. What is inductive reasoning? Inductive reasoning is the process of reasoning that arrives at a general conclusion based on the observation of specific examples. So technically, it involves looking for patterns, and take note of this, making a conjecture or an educated guess. Here is an example from our book. We're going to use inductive reasoning to find a pattern. For instance, a game show contestant is given the following string of numbers. We have 1, 2, 4, 5, 7, 8, 10, 11, 13, blank, blank, and blank. So she'll win $1,500 if she can continue the pattern and fill in the three blanks. Use inductive reasoning to find the correct answer. To find patterns in strings of numbers, it is often helpful to think about operations that can turn a number into the next one. In this case, we can use addition to find the regular pattern. So our solution will be, if we are given the sequence of numbers, we just need to look for some add-ons and look for the pattern on how we've got the next number. So in such case, 1 becomes 2 because we just simply added 1 in 1. 2 becomes 4 because we just simply added 2. And if you're going to look for the sequence of numbers, 4 becomes 5 because we just added 1. 5 becomes 7 because we just simply added 2. And we just simply apply that pattern. So in order for us to find the next number after 13, we just continue the pattern. We just simply added 1 in there, and then we just simply added 2, and we just simply added 1, so that we have this solution. So the pattern seems to be to add 1 and 2, then add 1, then add 2, so on and so forth. So a reasonable conjecture for the next three numbers is 14, 16, and 17. Take a look at this next example. Make a reasonable conjecture for the next figure in the sequence. So this is our sequence. The solution is just very simple. In the first four figures, the flat part goes from facing up to right to down then left. So ito up, right, tapos nag-down, tapos nag-left. So there's also a solid circle in each figure. So we have a solid here, solid circle here, solid, solid. The sequence then repeats with an open circle in each figure. So we have this open circle. So in the next one, the flat part should face left and have an open circle. So this is just very basic. Up, right, down, and then this will finally be our answer. Here is another example that is using inductive reasoning to make a conjecture. Letter A. When two odd numbers are added, will the result always be an even number? Use inductive reasoning to determine your answer. Letter B. How many pairs of numbers would you need to try in order to be certain that your conjecture is true? Here is our solution. For letter A. First, let's try several specific examples of adding two odd numbers. Remember that our problem here is to show if whenever we add any two odd numbers, and the answer is always even. We have 3 plus 7 is equal to 10, and we've shown that that is even. 5 plus 9 is equal to 14. 5 and 9 are both odd and the sum is 14. And we can actually continue to other examples. So in this specific case, since all the answers are even, it seems reasonable to conclude that the sum of two odd numbers will be an even number. And that specific reason or conclusion that you've made is what we call a conjecture. Here is the solution for letter B. A very important point about inductive reasoning is that you can try specific examples all day and always get an even sum, but that can never guarantee that it will always happen. For that, we're going to need deductive reasoning. What I'm trying to explain is this. In inductive reasoning, you can start from all the examples, and then at the end of the day, you're going to make a certain conjecture. Since you are just giving examples that would satisfy those things or those conditions, in our example here, those examples that would satisfy that whenever you add two odd numbers, the answer is always even, you do not prove the statement entirely. Unless mapakita natin na whenever we add any two odd numbers, the answer is always even. But the thing is, there are infinitely many odd numbers. Okay? So in order for us to prove that that statement is really true, ang kakailanganin natin later on is the deductive reasoning. A counterexample is one specific example that proves the conjecture false. To find a counterexample, you must start with a number or object that matches the premise of the conjecture. Pick this in a way that will give you an incorrect response. So dun sa example natin kanina, we have conjectured that whenever we add any two odd numbers, the answer is always even. Ngayon, if you wanted to prove na mali yung conjecture na yon, ang kakailangan mo lang is isang example na hindi magsasatisfy ng statement na yon. So now, remember, one counterexample is enough to show that a conjecture is false. But one positive example is never enough to show that a conjecture is true. So, doon sa example natin kanina, marami tayong binigay ng mga examples such that whenever we add two odd numbers, the answer is always even. Kaya nga lang, isang example lang nun will never be enough to show that a conjecture is false. However, in reality, whenever you add two odd numbers, the answer really is even. Kaya, actually, tama yung conjecture na yon. But on our level now, without using a deductive reasoning, we cannot actually prove that whenever we add two odd numbers, the answer is always even. Later on, perhaps if we are going to use the deductive reasoning, we can entirely prove that that was actually true. So in short, the inductive reasoning will just give us the idea on how things are being done and for us to formulate a conjecture. And in order for us to prove that that conjecture is true, kailanganin natin later on ang deductive reasoning. But if you wanted to prove na yung conjecture na nabuo natin is actually false, ang kailanganin lang natin dito is to have one counterexample. Now, how do we find a counterexample? For example, we have this conjecture. A number is divisible by 3 if the last two digits are divisible by 3. So, sinabi kanina, in order for us to find a counterexample, let's just try to some examples that would satisfy that specific conjecture. For instance, we'll pick a few numbers at random whose last two digits are divisible by 3, then divide the original number by 3 and see if there's a remainder. For instance, ito, 1,527. So the last two digits, 27, is divisible by 3, and eventually, when we divide 1,527 by 3, the answer is 509, and it was satisfied. Another example, 11,745. The last two digits is 45. And when we divide the whole number by 3, the answer is 3,915, and that is also divisible by 3. So, by this time, parang maiisip mo, at this point, you might start to suspect na, the conjecture is actually true. But you should not do that. We've only checked two cases, and there are infinitely many possibilities. Yun yung sinasabi kanina na you cannot prove a conjecture by simply using a specific example or even only two examples. Kasi nga, katulad neto, when we have 1,136, the last two digits here, 36, is divisible by 3. Kaya nga lang, when we divide 1,136 by 3, the answer will be 378 and 2/3. So in short, meron tayong remainder 2. So this counterexample shows that the conjecture is not true or the conjecture is false. Okay? Now, deductive reasoning. Deductive reasoning is the process of reasoning that arrives at a conclusion based on previously accepted general statements. So it's based on overall rules, not just specific examples. Okay, next example. Consider the following problem. Think of any number, multiply that by 2, then add 6, and divide the result by 2. Next, subtract the original number. What is the result? A. Use inductive reasoning to make a conjecture for the answer. And B. Use deductive reasoning to prove your conjecture. Inductive reasoning will be helpful in forming a conjecture. So our solution, by using inductive reasoning, letter A. Let's begin by picking a few specific numbers randomly. So we're going to pick a specific number and performing the described operations to see what the result looks like. So yung specific number natin dito is 12. Let's follow the process. Multiply it by 2 and that becomes 24. Then add 6 and that becomes 30. Divide by 2 and that becomes 15. And again, subtract the original number. So the answer becomes 3. And the result becomes 3. Now, let's continue. Let's pick 5 as a number. Multiply it again by 2. Add 6. The answer is 16. Divide by 2, that is 8, and subtract the original number, that is 3. So the result is also 3. Now, let's try 43 as our number. So multiply by 2, that is 86, add 6, that is 92, divide by 2, that is 46, and again subtract the original number, the answer is 3. It really seems that the answer is always 3. So, at this point, you may be tempted to conclude that the result is always 3. But this is just a conjecture. We've tried only 3 of infinitely many possible numbers. As usual, when using inductive reasoning, we can't be completely sure that our conjecture is always true. But at this point, it seems like it would at least be worth the effort to see if we can prove that our conjecture is true. Now, let's have a solution for letter B. That is by using the deductive approach to prove the statement. Now, the problem with the inductive approach is that we can check every possible number. Totoo nga naman because there are infinitely many numbers. Instead, we'll choose an arbitrary number and we call it A. Take note, A could be any number, standing for any old number. So, A could stand for that specific number or lahat ng mga possible number sa problem na yon. If we can show that the result is 3 in this case, that would tell us that this is the result for every number. Kasi nga, we'll just simply pick an arbitrary number A that can represent yung specific number na yon na hinahanap. Remember, we'll be doing the exact same operations just on an arbitrary number A. So we have here the solution. We have the number A, which stands for any arbitrary number. We multiply it by 2, the answer is 2A. We add 6, the answer is 2A plus 6. And then we divide it by 2. So that will become A plus 3. And then subtract the original number, which is A. So A plus 3 minus A, the answer is 3. Okay? So now we know for sure that the result will always be a 3 and our conjecture is proved. So again, why is it that we've proved it? Kasi nga, nag-pick na tayo ng any number A, arbitrary number A that could represent all the possible numbers. Okay, Take for instance this specific example. Consider the following problem. You pick a number, you add 50, you multiply it by 2, subtract the original number, and the result. Now, use inductive reasoning to make a conjecture for the answer, that is for letter A, and use deductive reasoning to prove your conjecture, and that is for letter B. Here is our solution for letter A. That is by using the inductive reasoning. Inductive reasoning will be helpful in forming a conjecture. We'll choose a couple specific numbers at random and perform the given operations to see what the result is. For instance, let us take 12 as our original number. When we add 50, that becomes 62. And when we multiply it by 2, 62 becomes 124. And when we subtract the original number, which is 12, the answer is 112. So, our result is 112. Okay, let's pick another number. 50 as our original number. We again add 50, that is 100. We multiply it by 2, that is 200. We subtract the original number, and that is 150. And the result is 150. So, kung ano napapansin ninyo kanina? Yung unang example natin, we have picked 12. And the final answer or the result is 112. This time, we have picked 50 and the final answer is 150. So it seemed that based on the relationships of these two specific examples, we can conjecture that, okay, a reasonable conjecture is that the final answer is 100 more than the original number. So in short, parang nag-add lang tayo ng 100 doon sa mga number na pinili natin. Specific numbers na pinili natin. But this doesn't prove the conjecture, as we've tried only 2 of infinitely many possibles. But at least, nakakonjecture tayo na, okay, if I'm going to follow this process, then parang yung result is that nagdagdag lang tayo ng 100 doon sa original number. Take note of that. Ngayon, this time again, in order for us to prove na tamang ang conjecture natin, we needed to use the deductive or the deductive approach. Now, solution for letter B by using deduction. Remember, we'll be doing the exact same operations, just on an arbitrary number A. Again, number A is an arbitrary number, and it can represent all the possible numbers. So our original number is A. We add 50, that it becomes A plus 50. We multiply it by 2, that becomes 2A plus 100. And then we subtract the original number. So 2A plus 100 minus A. So the answer here is A plus 100, where A is our original number. And that's it. Our conjecture was right. The final answer is always 100 more than the original number. So in short, you just simply add 100 to your original number, and that will become the result. We have already used deductive reasoning to form a conjecture, and in order for us to prove that conjecture, we just needed to use the deductive reasoning. And also, we've also discussed that in order for us to disprove that specific conjecture, we just need a counterexample. This time, we will compare inductive and deductive reasoning. Take a look at this one. The last 6 times we played our arch rival in football, we won. So I know we're going to win on Saturday. Did I use inductive or deductive reasoning? You may pause the video and analyze this problem. Now, here is the solution. The answer for this is inductive reasoning. Why? This conclusion is based on 6 specific occurrences, not a general rule that we know to be true. So, no team wins every game. We know that for sure. Kaya nga lang, parang na-conclude dito sa statement, I know that we're going to win kasi the last 6 specific times na naglaro sila, then they've won. Pero walang general rule na nagsasabi na sila lagi yung mananalo. So this is an inductive reasoning. Kasi binase niya lang ang kanyang argument on those specific examples na nanalo sila 6 times before. Here is another example. The syllabus states that any final average between 80% and 90% will result in a B. If I get a 78% on my final, my overall average will be 80.1%. So, I'll get a B. Did I use inductive or deductive reasoning? You may now pause the video and then analyze the problem. The solution is, that is a deductive reasoning. Bakit? Although we're talking about specific person's grades, the conclusion that I'll get a B is based on a general rule. So all scores in the 80s earn a B because that is from a general rule. Here is a summary of what we have discussed. We have discussed two types of reasoning, namely inductive reasoning or induction and deductive reasoning or deduction. Inductive reasoning is a kind of reasoning wherein we make certain conclusions from specific examples. Those conclusions can be based from our conjecture. A conjecture is a statement that we can form based on the specific examples that we have done during the process of inductive reasoning. In order for us to prove that those conjecture or that specific conjecture is false, we just need to provide a counterexample. But in order for us to prove a conjecture, one specific example is not just enough. So in order for us to prove that a conjecture is true, we needed to have a deductive reasoning. A deductive reasoning is a kind of reasoning wherein we arrive at a conclusion by basing it from the general rule, general idea, or a general principle.